Okay, this is going to be part 2 of the January 2019 Unit 1 physics paper on mechanics and materials. We went through the multiple choice questions before. This was the first exam for this new specification, which started obviously in 2018. So September 2018 was the first time students sat it. Once again, remember, you need a protractor, you need a calculator, and you need a ruler to answer these questions. Clarity, depth, and detail is what gets you marks, as I always tell my students. So make sure that whatever you do, it's clear, it's specific enough, so it has the detail required in the mark scheme, and you've put depth to show your understanding, okay? Otherwise, you will lose marks here and there. Okay, so we went through the multiple choice, and I hope you found it useful and that you've already watched it and you've given me a like, you've shared it with your friends, and you've subscribed, okay? So that really is important. I always forget to ask students to make sure that they've liked the video, because this gets quite a lot of views. I mean, some of my earlier videos, which started in 2023, they were end of 2023, so beginning of 2024. Some of them have seen 2,000 views already, but the only way they get seen is if they go to the top of the algorithm, and it requires you to show your appreciation by pressing like each time you look at it, writing a comment if there's anything that you have any questions. So here are the answers to the multiple choice that they give you in the mark scheme, and just really support the channel, because it is reaching quite a few people, but I want to get 1,000 subscribers as soon as possible. Now here's the mark scheme. So I put the mark scheme interspersed between the questions, and this might be worth you checking out. So they're telling you how to do your calculations and how you can lose marks if you don't show all your working in certain situations. So say you made a mistake when you're answering, you haven't shown your working, you go from full marks to 0. Yeah, in show that questions, you always need to show your working, okay? Because show that means mathematically prove that the answer that they want, you've been able to obtain it. And then there's qualitative answers, which you need to think about. So number 5 says quality of written communication. So those are like often 6-mark questions where they're asking you to put your thoughts down in a non-mathematical way. It may be some maths involved in your thinking, but it is the clarity of your communication qualitatively rather than quantitatively. In the quantitative ones, I forgot to mention that don't put too many significant figures. Work out how many significant figures you need to quote based on the number of significant figures in the data that's been provided. And graphs, I'll let you stop the video. Look at, if you've got a graph, it gives you some good advice in here about how it gets marked and how you should make sure you choose a sensible scale, okay? It tells you never to use multiples of 3, 7, obviously 9 I wouldn't use. I would try to stick to 1, 2, and 5, those kind of multiples. Okay, so here's the rest of the multiple choice questions. You can stop it to see how they've shown what is the correct answer and why the other ones can't be, but I've already gone through the multiple choice, but just in case you want to stop the video. Question 11, 12 of the multiple choice of this section are then here. So question 11 we're going to go to next. It looks like it's using A equals V minus U over T. So it's to do with acceleration and how they're scoring it. And question 12, it's to do with core practical 1. So if you've planned core practical 1, this is a theory question on core practical 1, and they do expect you to know the details of how to plan it, how to get the graph that you are meant to get in the core practical. So it not only is a core practical requirement, but you will be examined on it in the theory paper. Okay, so that's question 12. So here's question 11 of the first question of section B, which is structured. Okay, so what have you got to do? Answer all questions in the spaces provided. The graph shows the velocity of an object and how it varies with time. Describe how the acceleration of the object varies with time. So they just want you to change the graph into words. And you can see that even I made a mistake. I have scrubbed out one bit, which I then have clarified using the subdivision below with the arrows going down. From 0 to 9 seconds, I've said that there's constant acceleration. And I've used, it says your answer should include calculations. So I've shown that between 0 and 9 seconds, there's the steepness of the slope going up. And from the steepness of the slope, a velocity time graph, my year 9s know this, that you can work out the acceleration using the data on the graph. So it goes from 0 to 14, so it's 14 minus 0 divided by the time, it took 9 seconds, so I'm showing that I've got the numbers from the graph, and I'm putting the markings on the graph, and I would recommend doing that. It's part of your communication. So just these dotted lines show that you've read the graph accurately. So it's approximately 1.6 meters per second squared. And if you go back to the mark scheme, you'll see that they'll probably accept a range of values there. And then, but after 9 seconds, from 9 seconds to 17.5 seconds, there's a negative gradient, yeah? And the negative gradient means that there is a negative acceleration. So it's against the motion that it has at 9 seconds, okay? So it's, at first I put constant deceleration, but in fact, it only decelerates to 0, and then it accelerates in the opposite direction, if you like. Because remember, acceleration and velocity are vector quantities. So up to 12 seconds, you'll see I've marked that also on the graph where it crosses the 0 point on the velocity. So between 9 and 12 seconds, the velocity decelerates from the maximum of 14 to down to 0 again, okay? And you can see the slope is steeper than the initial acceleration between 0 and 9 seconds. And then I again worked out what the deceleration is, and I nearly made a mistake again. I was putting 14 minus 0, but since the final velocity was 0 between 9 and 12 seconds, and 3 seconds total, it goes 0 minus 14, which gives you a minus acceleration of 4.7 meters per second squared. Okay, two significant figures, because really that's all you can do with the graph. Okay, and then finally from 12 seconds to 17.5 seconds is the third phase. It now goes into the negative part of the graph. That means the velocity is in the opposite direction to where it started from. Okay, so once you do that, and again, if you could calculate it, you would get a value of approximately 5.5 meters per second squared in the opposite direction to the initial acceleration. So you should explain all that. So you have to describe means you add some explanation to it. The object changes direction, accelerates in the opposite direction at a rate of 5.5 meters per second squared. Okay? So you can go back and look at the mark scheme, yeah? And note it says time values are not exact. So that's why there's a range of values. There's time values depending on how you've read them, yeah? Do they exactly cross at those points? So some different people reading it from the graph may get slightly different values, and I seem to have got slightly different values to the mark scheme, okay? But it's within the range. Question 12 then is actually on the core practical, which I mentioned to you. So some of my students have planned this using exactly the same data, except they weren't going to use a wooden rod, they were going to use a card of length 10 centimeters, okay? So to read this question, it says a student carries out an experiment to determine the value for g, the acceleration of free fall. A short wooden rod is released above the light gate or above a light gate. A timer connected to the light gate is used to measure the time taken. So time taken is a dependent variable, and they want you to think about the experiment. So what is the independent variable? It will be the height above the light gate, okay, which I've drawn on the diagram from the bottom of the wooden rod to the top of the light gate, where it starts to disturb the light, okay? Timer connected to the light gate is used to measure time taken for the wooden rod to pass through the light gate. So you need to know the length of the light gate to be able to determine the speed, okay? So if you've planned this experiment fully, you should know all this, and it should be nice, easy marks for you. So the experiment was arranged as follows, and I've just put a few notes in bubbles, clouds, if you like, to show you key terminology that you need to be aware of. So when I do these questions, it's actually part of your learning. I'm teaching you the key things that you need to do. I underline words as I'm reading it because then it's active reading rather than passive reading, and I'm less likely to have misread the question. The student uses the equation v squared equals u squared plus 2as, where u is 0, and a graphical method, double underlining, to determine a value for g. So they don't want you to just do it once, plug the numbers into the equation, get an answer out, and that's it. They want you to know the graphical method. Most of A-level physics experiments expect you to get a straight line graph from whatever equation you have. Okay, state the additional measurements the student should take. So obviously time is already mentioned, in the introduction to this question. So the length of the rod, I've put it as L, in my diagram. Use the diagram the way I have to show your values, so you've got 2 chances to get the mark. Okay, so the length is a controlled variable. You need to keep the length constant because the light gate's actually usually controlled, not to controlling a timer. It could also be controlling a data logger, and the data logger will need to know what is the length of the rod that's going through the light gate to be able to give you the velocity automatically, which is the one that we're using in our school, how it works. So basically, you put in the length of the interrupter card, or the wooden rod in this case, and it divides the length by the time taken for the light gate, for the time that's triggered by the light gate, and it works out the velocity for you as well. So the other thing you need to measure is the height that you're dropping the wooden rod from above the light gate. So the distance from the light gate or the height above the light gate, either of those way of explaining it, when dropped. So the initial height, okay? And that's the independent variable. So you change the height and it affects the time, which affects the velocity, the final velocity. The initial velocity is 0. I then made a mistake here. So I've written the answer to part C. I started writing it here by mistake. So the first thing in a box should be, ignore that, that's in part C. We'll look at it in a minute. It says, describe how the velocity of the wooden rod, as it passes through the light gate can be determined accurately. So I went straight to planning the experiment rather than explaining the part here. So to determine the velocity, you need to obviously divide the length by the average time taken, So you want to do it more than once. You want to take the mean time taken in the light gate, and then you repeat, if it's accurate, to find the mean time. So the length of the rod divided by the time taken would be how you can determine the velocity, but then it says accurately, so it's double underlined. So when I've double underlined, it means pay particular attention to that. That's one of the marking points. So to do it accurately, you would need to repeat and find the mean time. And remember, when you're talking about average, don't say average. You've got to say the mean average, because average could also be the mode or the median, as you know, having studied physics. So this part, which I've written, repeat, find the mean average at different heights, etc., is the method, okay? So we'll ignore that for now and go to the next part, okay? So describe how the student can determine a value for G using a graphical method, okay? So yet again, I should underline or double underline graphical method. They always want you to do a graphical method. So it says repeat at different heights, above the light gate, and calculate V for each height using the mean time, okay? So that's what gets you the marks. So the main thing is to repeat at different heights, but obviously it's above the light gate, so make sure that it's crystal clear to the examiner, okay? Remember, the mark scheme is just for the teacher, it's not for the student. So when the examiner is looking at it, they don't want you to repeat the mark scheme. They want you to verbalize your understanding, and you've got to make sure you hit your message home 100% clearly, okay? They're not expecting you to write a brief answer like in the mark scheme. So I would write all that out, repeat at different heights above the light gate, and calculate the velocity for each height using the mean time. Okay? So you will definitely get the first mark if you put it that clearly. Then because v squared equals u squared plus 2as, where u is 0, yeah, you could say v squared equals 2as, where s is the height in my diagram. So then v squared equals 2gh, yeah. Remember that actually comes from loss of kinetic energy is equal gain in potential energy, where the mass is cancelled on both sides, half mv squared, and the half has gone to the other side, and the masses have cancelled. So if you think of it, if you put an m on both sides, it'd be mv squared equals 2mgh. So this is where this equation comes from. It's a conservation of energy equation. Okay, so if we put the v squared on the y-axis, yeah? So we put the v squared on the y-axis, and we put the height on the x-axis, like I've shown you, then the gradient will be what's left in front of the h, so the gradient will be equal to 2g, okay? So that's your second mark. And the third mark is explaining that the gravity can be calculated from the line of best fit on the graph. If v squared against h is used, the gradient will be 2g, okay? Now some students may say, well, I'm going to do v squared against 2h, and then the gradient will be g, okay? Now, my students, I made them plan this because I knew this question will definitely come up in an exam. It may not come up in their exam, but there is a high chance of core practicals coming up in theory papers. Hope that makes sense, and I think that's the end of question 12. Okay, we'll do one more, at least. Question 13 is on moments. Two brackets, it says, A and B. You can look at them on the diagram. Support a shelf of length 1.2 meters. Okay, and bracket A is positioned 0.15 meters from the left-hand end of the shelf, and a book is placed 35 centimeters or 0.35 meters from the left-hand end of the shelf as shown. So what I do is I've drawn all the forces involved and the distance that we want to work out. It says the normal contact forces of each bracket on the shelf are equal. In other words, it's saying FA equals FB on my diagram. I've called it force A and force B. I could have called it reaction A and reaction B. Okay. Determine the distance of bracket B from the left-hand end of the shelf. Now, if you think about it, we know all the distances and we know all the forces. There's only one distance we don't know, and I've drawn that in green. It's the distance to force B. Now, this is no more difficult than a GCSE question. Those of you who did triple science will have had to do, or those who did physics GCSE or IGCSE, will have had to have done moments in the Edexcel exam. Okay, so the first thing I've done is I've shown you that since FA equals FB, and FA plus FB are the upward forces, so these are the two upward forces, they must be equal to the downward forces because the shaft's not falling down. It's in equilibrium. So the upward forces must be equal to the downward forces, which have been given as 8.5 newtons, and the weight of the shelf and the weight of the book, 22.5 newtons in total. So those two equations are basically simultaneous equations, if you're thinking in terms of maths. So you know that FA equals FB, that means each of the F's upwards must be equal to the total force downwards divided by 2, which makes it 11.25 newtons, because the sum of the forces in a balanced situation, Newton's first law, the sum of the forces must be equal to 0. Sigma F equals 0 is how I put it. All right, so you wouldn't put it 11.25 newtons because the data given in all the question is two significant figures. Okay, you'll see the distance are given to two significant figures, the forces are given to two significant figures. So really all you know is that the forces approximately on each of the bookshelves supports A and B are must be about 11 newtons. Okay, all right. Then the second thing you do is you want to take moments. I'm just make sure you can see the diagram at the same time. You have to take moments now about the end of the shelf. So this is what you're doing next. Taking moments from the left-hand side of the shelf. I've called it O. Yeah, so taking moments about O. The anti-clockwise moments, some of them, the total anti-clockwise moments must be equal to the total clockwise moments about O. Yeah? So the 0 point on your measuring. So 0.15 times FA, if you notice that, plus X times FB, because those two are anti-clockwise. Because if 0 is the center of the clock, FA and FB will be moving against the clock direction, so anti-clockwise. Then the 8.5 newtons weight of the book and the 14 newtons are pushing down, so they're trying to turn the shelf clockwise, so you add them together on this side, and as long as you know how to take a moment, they'll give you 1 mark because they'll feel sorry for you, and then as the second mark is putting all the numbers in correctly into this equation, and you'll get the second mark. You've already got a mark for working out the forces are around 11 newtons, but I would use the accurate value 11.25 in my calculations. So you'll see you put the numbers in for the final part, taking moments from left-hand side. Sum of the clockwise moment, anti-clockwise moments equals the sum of the clockwise moments about the 0 point of the measuring, and you put the numbers in and change the subject of the equation round. You'll see that 11.25x will be equal to whatever's on the right-hand side, which is all known. Divide it to 3 significant figures, you get 0.861 meters according to the mark scheme. I didn't actually have a calculator. That's what they reckon. I then have changed it to 2 significant figures as shown. But I always do that. I show my answer to a more accurate number of significant figures, and then I do, in the final answer, I put my answer to 2 significant figures, because remember, all the data provided is 0.86 meters. Okay, I'm going to pause, upload this video to YouTube. Hopefully you'll give me another like, you'll share it with your friends, and you have already subscribed. And obviously once you share it with your friends, we'll get more subscriptions. Okay, I think I'm over 600 and something now. So having started in January, my aim is to get 1,000 before the end of the academic year. Okay, thanks for watching. See you in the next video. Bye for now.